Welcome to The Explainer. Today, we're tackling a force you feel every single moment of every day: heat. It warms your coffee, it cooks your food, and it literally powers our entire planet. But have you ever really stopped to wonder how it actually moves around?
I mean, think about a simple campfire. How can that one fire heat up the metal pot, the water that's inside of it, and your hands from a distance, all at the exact same time? It might feel like it's all just heat, but the physics going on here are actually pretty different from each other.
You know this cozy little scene? It's basically a perfect science lab for understanding heat. The way the pot's handle gets hot is totally different from how the water starts to boil, and that is different again from how you feel that warmth on your face.
So here's our game plan. We're going to start with what heat actually is, then we'll break down the 3 ways it moves around, one by one. And by the end of this, I promise, you'll be seeing these amazing physical processes happening everywhere you look. Let's get into it.
Okay, so let's dive right in with the most basic question. What even is heat? It's a word we use all the time, but what's actually happening on a tiny molecular level? At its core, heat is just energy. That's it. Specifically, it's the energy of molecules vibrating and zipping all over the place. See, everything is made of these tiny moving particles, and when you add heat, you're basically giving them a shot of espresso, making them jiggle and bounce around way more frantically. And here is the absolute golden rule of heat. It's a fundamental law of physics. The universe is always trying to find balance. So that energy will always move from a place with fast-moving molecules to a place with slower ones. The cooler object soaks up that energy and warms up until they both kind of even out.
So, let's talk about our first method, conduction. This is all about physical contact. Honestly, it's probably the most intuitive way we think about heat moving from one place to another.
So the crucial thing to get here is that conduction needs direct physical touch for heat to move along. Imagine a long line of dominoes. The energy passes from one to the next when they bump into each other, but the dominoes themselves don't actually travel down the line. That, in a nutshell, is conduction.
This is something we've all felt. You put a metal spoon in hot soup, right? The hot soup gets the molecules at the tip of the spoon all energized. They start vibrating like crazy, bumping into their neighbors, which bump into their neighbors, creating this chain reaction of energy that travels all the way up the handle right to your fingers.
And you see conduction everywhere. Butter melting in a hot pan, the handle of a pot on the stove getting warm. You know, that last example is really interesting. When you hold ice, it feels like the cold is flowing into your hand. But what's really happening is your warmer hand is conducting heat out and into the ice, transferring its energy and causing that ice to melt. Pretty cool, right?
Okay, so we've got heating by touchdown. But what happens when things really start to move? Well, that brings us to convection. This is where we leave the world of solids and jump into liquids and gases.
So this method is all about the actual movement of fluids. And by fluids, I mean liquids and gases. They carry heat from one place to another. So unlike conduction, where the energy gets passed along, here the molecules themselves actually travel, taking their heat energy with them for the ride.
This process creates something called a convection current, which is this powerful cycle that distributes heat. Think about water in a pot. The water at the bottom gets hot, it expands, becomes less dense, and it rises. The cooler, denser water from the top then sinks down to take its place, gets heated up, and rises in turn. It's this continuous loop that gets the whole pot of water hot. Convection is a massive force in our world. It drives huge weather patterns, but it's also how a simple space heater warms up a room. It's the engine behind that old saying, heat rises, and it's the exact same principle that lifts a giant hot air balloon right off the ground.
Okay, so what happens when there's no direct contact and there's no fluid to move the heat around? How does it get from point A to point B? Well, that's where our third method, radiation, comes in. This one's a little more abstract, but trust me, it's happening all around us all the time.
This is how heat can travel through the total vacuum of space or just right across a room without touching anything. It's not about jiggling molecules or flowing currents. It's pure energy, just like light or infrared waves, traveling in a straight line.
And the ultimate example of radiation? The sun. Its incredible energy travels 93 million miles through the emptiness of space just to warm our planet. It doesn't need air or anything to travel through. It just zips along as pure electromagnetic waves, and it provides the energy for basically all life on Earth. Just amazing.
Anytime you feel warmth without actually touching the source, you are experiencing heat radiation.
Oh, and here's a good one. A blanket doesn't make heat. It just traps the heat that your own body is constantly radiating, stopping it from escaping into the cooler air around you.
Okay, let's bring this all home. I'm going to give you a really practical tool to identify these processes for yourself, because once you know what you're looking for, you'll start seeing them everywhere.
This little table gives you a super clear, at-a-glance comparison. So, conduction, slow, needs touch. Convection, a bit faster, needs a moving fluid. And then there's radiation, the speed demon of the group, traveling at the speed of light and needing no medium at all.
So, just by asking these 3 simple questions in order, you can figure out the type of heat transfer happening almost anywhere. Let's go back to our campfire one last time. The pot handle gets hot because it's touching the pot. That's conduction. The air above the fire gets hot and rises. That's convection. And you feel the warmth on your hands from across the way? That's radiation. See? Simple.
Okay, so let's wrap this up. Here are the 5 most important things to remember from our whole journey through the world of heat transfer.
Just remember, heat always flows from hot to cold. It moves by direct touch with conduction, through flowing fluids with convection, and through empty space with radiation. And in the real world, all 3 of these are usually working together. Understanding this gives you a whole new way of seeing how energy shapes everything around us.
So next time you feel the sun on your skin, or stir a hot cup of coffee, you'll know the incredible physics that are at play. Heat isn't just about temperature, it's energy in constant, absolutely fascinating motion.